Hi guys, my name is Gouthaman Asokan and I'm a data scientist. And the topic that we are going to be seeing today is DALI, the model that has been uh, published by OpenAI. And what are the things that we'll be seeing today? The first is what is DALI, how it has been created, and there are two versions. There's a version 1 and version 2. We'll be seeing predominantly how the version 2 has been developed. We'll see a brief introduction on version 1, 2, and in version 2 there's a prior and decoder. So what it does in the actual architecture that we'll be seeing, and how they have evaluated this DALI and what are its limitations presently. So these are the things that we'll be seeing today.
Hello.
Yeah. Hi.
Yeah, hi. Folks can hear, so I hope everybody can hear fine.
So one of the things is they haven't published their code yet. So we'll be seeing the research paper in which they have told what is the architecture that they have with which they have built, and we will be seeing a demo of how these images are being published. So DALI is essentially the name where it comes from is there is this artist called Salvador Dali and the Pixar movie WALL-E. So both they have combined to give this name of DALI because of the artistic nature of the model and it being a AI. So they combine these two words to create this model called DALI. And this is essentially a neural network. And the first version, what it had is it is essentially a autoregressive transformer. So it has a large number of parameters. So what they did is they essentially took all those sentences and images from the internet and built this model. They had 250 million pairs of images and text which they took, and they had a huge model which had 12 billion parameters, and with which they built this model. And so it is the version 1 was able to integrate different things like animals in different ways. If you describe, it could generate that. It was very good at image-to-image translation, and it was able to render text. So this is the first version. The first version had a simplistic approach compared to the version 2. So this is an example of a version 1 image. So what they do is they tell this sentence called a baby daikon radish near to walking a dog. This is a very abstract sentence, and it's very imaginative. But the DALI is able to interpret this sentence very quickly. The addition to 2, it is able to automatically create that, and it is walking a dog. So it's able to attach the dog with this radish and able to create this image. And there are several variations that has been created for the same sentence. So we will be seeing that both in the version 1 and version 2 for a given sentence, there are numerous images that has been created. Version 1, what it essentially does is it's a transformer language model. It's an autoregressive transformer, and what they do is they give the images and the sentences as a single stream of data. And to model this as a distribution is what this transformer is essentially doing. And for each of these sentences that has been given, the version 1, what it does is it creates 512 different images for the same caption, and that is this another OpenAI model called CLIP. So using that CLIP model, what they do is they are getting what is the top 25 images for this caption, and they are displaying only those 25 images. So this is how it is being built. We will also see how CLIP works in upcoming slide briefly. In version 1, essentially it has 2 stages. The first stage, what it does is the primary objective of it is to make the spatial resolution lesser. So, given an image that is of 256 into 256, and this is RGB image, so into 3. So it essentially, so each image would have 256 into 256 into 3 spatial vector. And what this discrete variational autoencoder does is it reduces that into a 32 into 32 grid of image tokens. And with this variational autoencoder, they compress this into this 32 into 32, in which each of this grid value can have a value that can have 8192. So from this large set of values, any value it could take. What is the advantage of this model is it essentially reduces the image context size by a factor of 192, because we are essentially taking this 256 into 256 into 256 into 3 and making it into a 32 into 32. So that again compresses the image by a factor of 192, and this in turn helps in training the transformer that we need. So that is why this discrete variational autoencoder has been hugely helpful in the version 1. So once this image has been compressed, the second thing what they do is they concatenate the text encoding. And the text encoding, what they do is they use this byte pair encoding. So with this byte pair encodings, they convert the sentence into this 256 byte pair encoded text tokens, and we have this 32 into the 32 image token that we have got from the variational autoencoder. We concatenated both the things, and what we do is we send it to a autoregressive transformer. So this autoregressive transformer, like in NLP, what we do is we do this sentence completion, right? For example, given one word, you compute the second word, and from these two words, we compute the third word. So in this way, the autoregressive transformer works. In the same way, what they do is they try to model the joint distribution over the whole of the text and the image tokens. And with this, they find a distribution, and this transformer will help to create the image given the sentence. So this is the basic architecture of the version 1 of the DALI.
So Gouthaman, just to define Dali again, Dali converts text to image. Right?
Yeah.
Okay, it's a text to image converter. It's a sophisticated neural network by OpenAI Lab, and there are two versions, Dali 1, Dali 2. Right? Yeah. Okay, thank you. Thanks.
There are some of the things that has been lacking in version 1. They integrated much more sophisticated ideas into the version 2, in which it is able to produce even more impressive results. So here, if we see bear playing a guitar, a squirrel playing the basketball, so all these things, given this sentence, is automatically able to create those images with this version 2 of the DALI. So what is the differences from version 1 compared with this of the version 2? So what is the additional advantages when we use the DALI 2? The first one is it's able to not only recognize the individual images, it's able to understand the relation between the images. So in DALI 1, what we use would only match the sentence to the image, but in DALI 2, it's able to understand how much similar two images are. So this relationship between the images is something the version 1 was not able to interpret, but the version 2 is able to interpret. The second thing is the major thing is the resolution. So now when we give us a sentence, it's able to lot more able to make a higher resolution image. So compared to the original DALI, now this version 2 has a 4x better resolution. So that is another advantage. And the last advantage is able to transform those images. So here, if you see, there is a picture of a puppy sitting in the sofa, the chair, and we can just input what we need. For example, if cat is sitting in the chair, and it's able to automatically reprocess the image into that way. So this kind of image understanding the DALI 2 does have. So DALI 2, so it's able to understand this images well, and able to create this high resolution images with a lot more in context. So how it is able to do it is, first thing is, what they have done is, they have built this model called CLIP model, the OpenAI, which is the contrastive language image pre-training. So I'll just tell about it in the next slide, how they have built it. So with the help of CLIP, what they're doing is, first, so the idea of this model is, we give a sentence and we will get the image. So here what happens is, we give this raw text, then this CLIP text encoder, what it does is, it converts the raw text into the text embeddings. So that is the first thing that it is doing. So once we get this text embeddings, there is a prior model that is in version 2, DALI 2, and that prior can either be an autoregressive prior or diffusion pair. I'll brief on more on how this autoregressive or diffusion pair works in upcoming slide. So we have this prior that converts this text embeddings into the image embeddings. And again, we have a decoder. So this is a diffusion decoder that converts this image embeddings into the final image. So essentially, the DALI 2 is a single stream of pipeline where we give the raw text, we get the text embeddings from the CLIP text encoder, and from the text embeddings, we get the image embeddings with the help of the prior. This prior can either be an autoregressive prior or a diffusion prior, and from this image embeddings, we get the final image with the help of the diffusion decoder. So that has been represented in a mathematical form here, where we have this probability of getting the image given the sentence. So this is the image, and its corresponding sentence, or the caption is what this is. So that can be written as the probability of the image and the image embedding given the sentence is what we are having in this pipeline. And again, this can be made into a product of two probabilities. One is the probability of the image given the image embedding and the sentence, and probability of the image embedding given the sentence. So we convert into this in this way. So this is a mathematical representation of how this model works.
So Gouthaman, 2 points. One is, this seems like using the CLIP as a backbone network, right? OpenAI CLIP.
Yes, yeah.
That is 1 point. Second, this formula looks like a Bayesian conditional probability, right?
Yeah. So,
okay.
Yeah, it's a conditional probability.
So what is the condition on the text input?
So you're telling about the
yeah, what kind of conditions the text will have to any say, for example, does it have any limitations as to the amount of words that should have, or in a specific order should it be phrased? Suppose, say, I tell the AI to draw a monkey on a tree. Okay, so or something else, say, which doesn't really have any imagery to it, any direct imagery to it. So does it just think about an imagery given any sentence?
Yeah. So the one of the things is, first is the caption length. There's definitely a caption length. I'm not sure how much it is, because they would have got this text embeddings for a given sentence size. So there is a size. So, and your question is actually, you tell it again.
No, sir. My question is, if I can just rephrase it. Given a text, what are the conditions on that text? What are the input conditions on that text? Could it be any text for which an imagery is generated
Yes.
by the AI?
So what they have done with DALI 2 is they have got all the data from the internet. Say for example, Instagram, where you have the image and its caption. So
Yep.
they have got all those images and all the caption that's accompanying with it and train the model. So if you give any sentence, it should be able to able to generate the image. There could be exceptions, of course. That is the limitation here. So if there are some words that is not in the training data set, it would create it would not create those expected images.
Okay, so Dali is already a trained model, right? So it's already a trained model. It's that we can use in a Python or some code with it.
Yeah.
Thank you.
So, this is the architecture of the DALI 2 model, and so if you understand this, it will be easier on how essentially this model works. The first thing is, so there is this dotted line. The diagram below the dotted line is what essentially DALI 2 is. And the above line is how the clip model is being trained. So I'll tell how the clip model is being trained. So okay, I'll just complete how the clip model is being trained, and then we will see how the DALI 2 model works. So clip model is essentially again another algorithm that has been published by OpenAI, and this is helpful in getting text embeddings. So here, if we see, we have a set of sentences, we have a set of images, and we have a text encoder and image encoder. So, and we have this matrix where there is this text encoding and this image encoding. We get this matrix with the image and text encodings. So, how do we compute the loss and backpropagate the losses? Essentially, what we need is we need this image to text encodings, this diagonal to have the maximum value, because that is the expected sentence image similarity that we want. So that to have the highest value and others to have lower values. So based on this, we will be back propagating the loss and updating the weights of the text encoder and image encoder till we get the desired result of having the diagonal to have the maximum values. So once we have this, we'll be having this clip model that is able to tell given any image and any sentence how likely that these are a pair, that this sentence represents this image or this image represents this sentence. So that we'll be able to know with the help of this clip algorithm. And essentially what they are doing is here too they are taking the data from the internet, training the model, and we now have the text encoder and the image encoder of the clip pre-trained model, and we'll be using this in the DALI 2. So here once this whole model is being trained, we have this text encoder, and in DALI 2 what we do is the upper part of the architecture is the clip model, where we have this text, we have this image, both goes to a encoding part, the text to the text encoder, the image to the image encoder, and we have a clip objective which updates this weight so that this clip model is now able to understand which text is related to which image. So we have this clip objective and we have this pre-trained clip model. So once we have this, then we come to the DALI 2 model. So in DALI 2, what we do is we give this sentence into this text encoder, and we get this text embedding. So once we have this text embedding, there are two parts. One is the prior and next is the decoder. What the prior does is, the prior, it converts this image in embedding into the text embedding into the image embedding. So we have the sentence, the raw sentence, that we send it to the text encoder to get the text embeddings, and the text embeddings to image embeddings, we get it with the help of prior. And once we have the image embedding, from that to the actual image, we have this part called decoder. So this is how the whole DALI essentially works. It has a clipped text encoder, it has a prior, and it has a decoder. And we have the final image. So this is how they have developed it. We will be seeing how this prior is built and decoder is built in the upcoming slides. If you guys have any doubt, please do it.
Can you just repeat this prior and decoder once?
Yes. So the prior, what is the objective of the prior is, we have this texting embeddings. We have to convert into image embedding. So that is the objective of the prior. So now finally we have the image embedding that we need to be creating into the actual image. So that is the part where the decoder helps.
So we have two images, right? Prior, there are two boxes. Both the things does the image embedding, right?
Yes. So this is the autoregressive pair. This is a diffusion pair. There are two ways in which this could be achieved. They have tried with the two ways, and diffusion pair is what they have found to be the optimal way.
Okay, thank you.
So the diffusion model is one of the things they have been using. So both in the prior and decoder, they have been using this diffusion model. This is something that has been not explored much in the computer vision, and after the publication of this DALI 2, the diffusion models are becoming famous. We'll be seeing a brief introduction of how this diffusion model works. So essentially, the diffusion model here, it's being used both in the prior and decoder. It works by taking the actual image and corrupting it by adding a noise. So this noise is a Gaussian noise, and we add it for a number of steps till it becomes a pure noise. For example, so here this x3, this x2, x1, x0. So what they do in this x3 is they take an actual image and they add a little bit of a Gaussian noise to get it to x2. Again, they may make add a small amount of Gaussian noise, and again they get into x1. So they repeat it for a number of iterations, and finally when we get to this x0, we'll just have this noise. So here if you see this thing, it's just a noise. So we get just a noise. So this is the first step in the diffusion model. Now again what they do is they try to reverse the whole process. Now this is the reverse process where they have this noise, and they have this iterations in which step by step we are able to get the actual image. So this is the way in diffusion model works. The first part is they have an actual image, they add the noise to get the whole of the noise. Once this process they try to reverses. And how is, like, the objective is, given a noise, it needs to produce an image. So
using the last function, you try to create the original image, right?
Yeah. So we use a neural network here, and this is a mathematical way. So we have this image, and we'll be adding Gaussian noise. At each step. So in that way, we'll be getting the noisy image. From the noisy image, now for each iteration, we use the neural network to get the next. So x3 we know, x2 we know. So what is the target image we know? So how do we create that? So that will be getting to the neural network, and in that way we'll be getting the actual image. So this is how the diffusion model works. And OpenAI actually have published a number of research papers. One of them is this GLIDE model. I think it's a guided language image diffusion for the generation and estimation. So what they do with this GLIDE model is they again use it for the image generation, and so this is a straightforward diffusion process. The GLIDE model that the OpenAI has published. What they do in addition to the simple diffusion layer is they add this sentence in with the noise. For example, here if we see, so according to the diffusion layer, we have a noise, and with each step, this noise is being created into the actual image. So in the GLIDE model, what it does is it adds this additional textual information. So for this image, what is the text encoder? So that what they do is they use this transformer, and from the decoder they get the embedding and use that embedding in addition to the noise to get the final image. So that is the major variation with respect to a simple model that the GLIDE has done. So GLIDE essentially uses the diffusion model with the text embedding to get the final image. So this is the GLIDE model. The GLIDE model is also used for the image generation, and we'll be seeing how this has been incorporated in the DALI 2 model. So, and another the thing that could be as this white prayer. So one of the things that we see is we have this raw text, we get the text embeddings, and we get the image embeddings, and finally the image. So there are different ways in which this could be approached, right? Like for example, from the raw text itself, we could get the image embedding and get the final image. So essentially, even without the prayer, we can just take the text embedding as the input, and we can try to create the image. So that is one way of creating the images. Or we can directly from the text embedding itself, we can get the image without the decoder part. So without the prayer part or without the decoder part, even we can be creating the images. So what is some of the challenges that we face in such a scenario? They have explained. So here, if you see, they have given this sentence called a hedgehog using a calculator. So this is an animal that is being using a calculator. So we have our DALI 2 model, and here, if you see in this, they are not using a clip text embedding. They're using the raw text, they're using a decoder and getting this image. So that is the first iteration they have tried. In that iteration, it just gives a hedgehog. It doesn't understand that the hedgehog should be using this calculator. These are the type of images that is being created. And there's another iteration where they have converted this raw text into this clip text embedding, but they haven't used the prayer. They just go from the clip text embedding to the decoder and to the final image. So this is the second iteration they have gone. So here, this is the image that has been created. So here, if you see, there is still a calculator, and this there's still a hedgehog, but the hedgehog is not actually using the calculator. So that kind of a context, it's not able to understand with this particular architecture. And finally, the architecture that we have been seeing, we get the raw text, from that the clip text embedding, we have the prayer, we have the clip image embedding, and we have the decoder, and finally the image. So in this particular architecture, we get the desired image that we want. So they have been trying with different permutation and combination, and finally they arrived at this architecture, which has been the most effective way of building the image generation.
Here, how do we know that which dog and what kind of calculator? Is it predefined already?
No. So it will be creating its own versions. It's just that how relevant to the sentence the image is.
Yeah.
For
So the
example,
image, there are, multiple permutation possible, right?
yeah.
So, how do we, justify which one is better? We
Yeah.
have to view.
In here, yeah, it definitely it's like this is essentially art, right? Like it's very subjective. Even the evaluation techniques that is being used here is by human evaluation. For example, here they are trying 3 different kind of architecture. They use try to show it to a human, the sentence and the images, and ask which is the most likely image with the sentence. So people would be pointing this to the sentence, and that's why this model gets a higher evaluation score compared to the other.
Okay.
So yeah. So this is the doubt you are asking.
I mean, you see, if you have the text is lengthy, right? Or if you have more
So
text.
if you make it even more, like for example, the hedgehog, what is the characteristics that you could give? Again, for that, the image would be even more precise.
Yeah, I mean, the problem is somebody has to evaluate depending upon what he is looking for. So if you have seen usual training and all, no, we are giving a classified model or whatever, right?
Yeah.
An image which we wanted to classify initially for training.
Yeah.
And in this particular case, we don't know what it will generate.
Yeah, it's the unsupervised model. So the image generation, it could be anything. And the good thing about Dali is it produces much more variations than other models.
Yes. But
This is
if
like
you can give a score, no, some artistic kind of score,
Yeah.
then it will be good. Otherwise, it will be very hectic to look at.
They have made a score, like I'll show in the evaluation.
Okay. Thank you.
So I think this is like Magenta, generative AI, where the error, precision and accuracy are not the intended thing, but it's more about an artistic outcome that is relevant.
Yeah.
Yeah, and then even then, right, there should be some sort of evaluation.
Yeah.
So the evaluation has been done. Like for example, like even in this image, so we have the sentence, we have the 3 images. So they have made a score for each of those different architectures and found which to be the most effective thing.
Like, can we ask for an ensemble of all the outcomes that might come out, all the probabilities? Can we select suppose say there is a Gaussian distribution of the probability of all these, of the objectives. Can we select a range of probabilities that might come as an output? Like one is here a hedgehog, but with a different calculator, with a different background, with a different keyboard.
Yeah. It does produce variations. I'll show in the demo. So for a given sentence, it does produce this variation. But these variations, they have given, like for example, in the demo there'll be 5 variations. Even in the version 1, if there has been a lot of images, but they use the clip to make the top 25 results. So in that way, for a given sentence, there'll be like different variations that could be.
Okay. Very interesting, sir.
So this is why we use the prior and decoder in the architecture, and so we'll be just seeing what is this prior model and what is this decoder model that is being used in Dali 2. The prior model, essentially what it does is it gives this captions, which is the UI, and it converts them into this text embeddings, which is the clipped text embeddings. So this could be done in 2 ways. One is the autoregressive prior, and the second is the diffusion prior. In autoregressive prior, what we do is we have for the so we have for this given text embedding, what is the image embedding? We know because we have this pre-trained clip model. So for each sentence, we know what is the embedding, equivalent image embedding that we'll be getting. So these embeddings will be having as the target space. And once we have this target space, we'll be creating this clip image embedding into a sequence of discrete codes and autoregressively predicting for the given clip text embedding what is the image embedding. So the prior model, the objective is the given input is the clip image clip text embedding, and the output is the clip image embedding. So how do we achieve the clip image embedding is the thing. So the first is the autoregressive thing, where we convert into a sequence of discrete codes and predict autoregressively. The second is the diffusion pair. In the diffusion pair, as we have seen in the diffusion model, we have this text embedding, and we use this Gaussian diffusion model conditioned on the caption Y to get the image embedding. So we can either be using the autoregressive pair or diffusion pair. And the research paper have told that the diffusion pair to be the most effective pair in DALI 2. So autoregressive pair, again, one of the things that they have been using is the image embedding they get has a huge dimensionality, and they reduce this dimensionality by using the PCA. So once they reduce this dimensionality by PCA, they are only using that as a target variable for training the autoregressive pair. And autoregressive pair is conditioned on the text caption, the text embedding, and the dot product of the text embedding and the image embedding. This is because like we are using the clip idea for training the models, so you'll be obviously using those variables, and the resulting sequence is predicted using a transformer model. So once we have this clip text embedding and the target image embedding that we have reduced in dimensionality with the help of principal component analysis, we'll be able to predict the sequence of the image embedding using this transformer model with casual attention mask. So this is the way in which the autoregressive pair works. The next is the diffusion pair. So the same thing of converting this text embedding into image embedding, we can also do it with the help of this diffusion pair. So in diffusion pair, what it does is it has a transformer, decoder only transformer, and what it does is for each of the the noise that we have, we need to be finding the next time steps image. So in this way, the decoder only transformer produces the next time step, and for a iteration of in a span of iteration of time steps, we'll be getting the actual image. The loss of the pair is being told here. So how much time steps we are taking to get to the actual image. So that is the 1 to t. And that we get it by the mean square error. So the mean square error is Zi is the actual embedding, and Zit is the embedding at that time step of t. This is the time step, and the text embedding. So with this, we will be able to find what is the loss, and we will be back propagating that to update the weights of the transformer. And once we have this whole sequence, we'll be able to use this diffusion pair to get our final image embeddings. So they have used the logic of two of the pair models. One is this clip model that they have used, and another is the glide model. So the glide model is also a image generation model. So what they have used from the glide model is, in glide model, they have used this diffusion with the text to get the actual image. So in DALI 2 decoder, what they are using is, they are using this noise to get to the final image. With that, what they are doing is, they are concatenating both the raw text and the clip embeddings to get to the final image. In this way, when they clip these things to get to the final image, they are able to get even more accurate images. So this is one of the techniques they use in this DALI 2 decoder. And DALI 2 is able to make super resolution images. So how it is able to do is they use two techniques. One is the Gaussian blur, and the second is the blind super resolution. So these are the two techniques they use. So given a blurred image, they get to a upsampling so that you get a high resolution image. So with these two techniques, they have this final image that is 64 into 64. They upsample from the 64 into 64 into 256 into 256 image, and again from this they upsample into this 1024 into 1024 image. So in this way, they do this upsampling and get a higher resolution image in DALI 2. Another one of the things that DALI 2 is able to do is it's able to create variations of the same image. So how do we create a variation of the same image with the DALI 2 model that we have trained? That could be achieved by giving the original image to the clip image encoder. So this clip image encoder is the pre-trained encoder that we got from the clip. So with this, we are able to get the embedding for this image. And what we will be doing is, so up to this is one part. Here we get this clip image embedding. So this clip image embedding we have got from the clip, and this we will be sending it to the DALI 2 model of decoder. So this decoder for this image embedding will interpret how this embedding would look like, and it will produce images. In this way, what we can do is we can have a single image, and for that, what are the different variations that would be produced. So that is the basic idea in which we have the given input image. We use the clip model to get the image embedding, and that image embedding into the DALI 2 to get the variation of the images. So this is how it is being done. We'll also be seeing in demo how, like for a given input image, there could be several variations that could be created. So DALI 2, so this is the evaluation. This is that they have got. The unclip is the DALI 2 model, and the glide is glide is also the image generation model, and DALI 2 is also the image generation model. And they have used the human evaluation to see how good the images are, and three respective things. One is the photorealism, and second is the caption similarity. Third is the diversity. Photorealism is how good the image is believable for the human eyes. So that is the first thing they are evaluating in, and that is seems to be that. And caption similarity. The caption similarity is for a given sentence, how close the image is. So that is the second thing they are seeing. Both this photorealism and caption similarity, we are able to see that it's very close for both the glide model and the DALI 2 model. So where the DALI 2 has a lot of impressive thing compared to the glide model is it has a lot of diversity. So here if we see the glide model compared to that, the DALI 2 model is able to produce a lot more diverse images, and that is one of the key strengths for the DALI 2 model. So now we have seen how the architecture of the DALI 2 works and how good it is compared to the other models like a glide model. So now what is the significance for this? So what is the significance for the DALI model is it's able to express images that's even difficult for humans, and it's able to express them in very creative ways. And this creativity is what this DALI 2 has achieved a lot more effectively. We'll be able to know how good is AI able to understand the NLP. So this DALI is a bridge between the NLP and the computer vision. So how good it is able to understand the language models, and from that, how good it is able to create those images. And also, it will be interesting to see how this DALI 2 is being used to expand our imagination, and whether it could be used, it is going to be used for a good or bad, and whether it is going to be having some ethical consequences. Because once they haven't made it open source, and OpenAI, what they told is it could be used in unethical ways too. So that is one of the reasons why they haven't made it open source. So another thing is the limitations. So the limitations, as it comes with the other models, DALI 2 has limitations. One is the data labeling. So we just take the whole data from the internet and train it. So suppose there is data in the internet where, for example, a caption and the image just don't match. And if we are given that to the model, it has trained. It is not trained correctly, and again that would be showing in the generated images. So that is one of the problems. And then the next is again, it should have seen the text that for which it is creating the images. So even though we are taking the whole of, for example, the internet and giving it, still if there are words that it hasn't seen, and if we give that in the test cases, it would be trying to create images that are totally irrelevant to the caption that we have given. So covering the whole of the vocabulary is still a challenge. And the third thing is the open source. So now it has been released only to a set of users with the code not being given. So that is also one of the limitations for the DALI 2. So this is the essentially what they have told in the DALI 2. So they have given the architecture, what is the things in which it can be the other state-of-the-art models, and what is its limitations. Now we can go to the demo. Before that, if you guys have any questions on the architecture, please do. Okay, probably we can go to the demo and just show the demo for this. So DALI 2 gives this access for creating those images. So yeah, I got it just 2 days before, and it gives like for a month, the opening month, some 50 credits. So you could be creating 50 images, and after that, 15 credit for each of the upcoming months. So in this way, they have planned presently. If you guys can tell some sentence for which that image could be created, any idea from you guys?
Gautam is teaching Dell E 2.
Which one?
I'm saying Gautam is teaching Dell E 2.
I don't think.
Let's try.
Yeah.
Okay, any human probably. If your pictures are already there with that name, then it should.
I don't think Gautam. Okay, I'll just teach him. I actually make it a human teaching DALI 2. Okay.
It may not take proper noun. Yeah. It will give 25 best images. Huh?
We'll be getting 4 images actually.
Okay.
So this is the images that we have got for this. So how it is interpreting, like it will be interpreting in different ways. So here, just more of the person teaching is what the first key things happen. The fourth is interesting. So it has told in this way. Uh,
But very good.
so I'll probably what it does is I'll also show two more examples, and after that probably we can make other examples. Upload an image. So here what I'm doing is
Sorry, you can try astronomer sky watching.
I started watching this guy.
Astronomer sky watching.
The spelling correct?
Yes, yes.
Yes, yes, it's correct.
So it's able to create those images.
Nice. So at present we don't have the choice of images, right? So the variables of the images we cannot decide, isn't it? Just that whatever it gives, we need to take.
Yes, yes. It will always be like that. Only way we can control it is like we can make it even more descriptive. The sentence.
Okay, fine.
I think next the automatic movie generation is coming. So all you have to do is maybe in the future versions of this kind of technology, you write a story or a script, it will generate a movie or web series for you essentially. So video production and not just art or image.
Yeah.
So I think more sophisticated art as well as video production is upcoming.
Yeah.
With the required actors, right, Vivek?
You will get some AI actors, not the usual, Amir Khan or whatnot.
Actually, when we say generative AI, I think this is generative AI, right? We can call it generative.
Yeah.
So now I think the images that we are getting when we give a description is essentially images that already are present in the on the web. Is it possible?
It is being created by the.
It's being created. Okay, yeah, that's what. So if I say something like, say, Bruce Lee performing surgery.
Okay.
Okay, so that.
I think that's a hypothetical situation, no? So.
Like how good it is able to.
Yeah, maybe it might give Bruce Lee breaking somebody's head or something.
Performing surgery. Bruce Lee, yeah.
Yeah.
Able to.
I mean, I'm sure.
Actually, yeah.
Oh yeah,
Wow.
he's doing
Amazing.
it. Yeah.
Amazing.
Yeah, he's doing it his way.
Is that
And how do you get this account, Gautam?
So you Dali, you give a request for getting the API.
Mm-hmm.
So I was in the wait list. I was given access.
Yeah, the problem with OpenAI is they put us in the waiting list for so long, and
Yeah, I had tried for GPT-3 long back, but
same here. GPT-3 I also tried. Yeah.
I'll just show two more examples.
Yeah, please go ahead.
Is there a possibility that we might get something like a Python binding where we could use it in a program in combination with other AI modules?
It should be available, I think.
No, they won't make it open source so easily, right?
Yeah.
Open source. Out of
they won't make.
Yeah.
So now we have this famous painting, and we could get the variations of the image. Like I have shown in the architecture, they get the image embedding, and then they send it to the Dali for creating the variations of it. Yeah, so the context remains the same, but it has produced the variations of the same image.
Yeah.
That is another thing. Another thing is like it's able to understand the context and turn that image. For example, here we have this. I'll try with this and see what happens. So we could erase this thing and then. Okay. So yeah, just the road, it's replacing the car with the bus. So it's interesting because it's going in that direction, but it's coming this way.
Hey, Gouthaman, variety of GAN variations also do these tasks, right? Historically, so there are many GANs we have seen before, but yes, this may be more accurate, possibly.
Yeah.
You remember some of the GANs will do some of this stuff, right?
Yeah. It's doing more effectively, but major thing is that the DALI 2 is able to create high resolution images for whatever text we have.
Okay. Okay. Yes.
Yeah, I think behind the scene it is GAN only, Vivek, I think. Conceptually.
Yeah, I mean, architecturally it is similar. You may say that, yes.
Yeah.
GAN, yeah, it's little similar. The thing is, they are using this clip model that they have built for image generation. That is the main thing with which it's able to produce like for any given sentence image.
So any meme, there is a question which came, meme generation. So I guess it will generate something. Whether you consider that a meme or not is up to us.
Also, if you given a vision for your company, you want to write a vision statement, you can generate a logo out of it, right? That will be.
Yes.
Yeah, and one of the things I've told is,
Vivek, what is your mission of your CellStrat? Just write it. Let's see what logo it generates.
Yeah, we will try that. Let's try this one, meme on artificial intelligence.
No. What is the vision of your CellStrat?
Oh, we want to, do AI disruption.
You want to put yourself to a test.
No, let's generate a logo for your company.
Okay, you can type this logo for a company working in the field of AI disruption.
Okay.
yeah. So the meme, it's coming different captions, and I don't know which language it is.
So the logo for a company working for AI disruption.
You'll show some bomb or something. Total disruption.
Interesting.
Yeah, there you go. Something comes up.
Yeah. Surely something will come, but
Yeah. The captions are anything that is actually not that good, even as the version 1. What it is able to do very good is like the portraits, those things it's able to do it very good.
And okay, this is on the image, right? Okay. Interesting, man. I don't know where the world is moving with all these things.
See, the thing is, currently we have copywriters, authors, artists, movie producers, right? Video folks. So this is generative technology. So this can lead to a lot of creative, modeling and augment, hopefully not replace, of course, various artists and creators and movie producers of the world. So it is kind of coming. It's getting better and better every year. With every GPT version, we have seen improvements. Yeah, future looks exciting and also scary at the same time.
Yeah, it is going to replace so many people, man. So many jobs.
Yeah, but a lot of new jobs as well if you can master this technology. Yeah.
There is nothing like someone will generate. There is nothing like mastering, if you ask me. Because see, one big company who has money, right? They will kind of train all the junk in the world and provide an API, right?
Hmm.
Yeah. So I don't.
But whoever has the image, right? Like a Google, they will get. They are the main people who can make money out of it.
Yeah, that's what I'm saying. People who have big companies who have money and all this hardware, right? And, yeah.
We can just use what they are doing. Yeah.
As Vivek was mentioning, it won't create many jobs, but yeah, I think some copyrights issue, all these things will come into data privacy, all these things.
See, I have one doubt. See, sites like Shutterstock, Corebase, and all, when you give a search query like this, that also throws n number of images very similar way, no? Whatever it has, images, videos, graphic work.
Those are already
Yeah,
Well tagged,
generated, right?
well tagged and well
Yeah.
articulated. So I'm just wondering.
No, those are stock images, Venkatesh. Somebody has taken those photographs. They are not
Yeah.
artistically generated photos. So
Okay.
Shutterstock, etc. They are stock images. They are real photos somebody took and willing to sell for a license fee. So
Okay.
this is generation. This is art. What we are seeing here is artwork.
Artwork. Okay.
yeah.
And
This is
let's
artistic
try to do
recognition.
the same thing what we gave. Just let's say that AI logo for a description, company for whatever we give. Let's try to give let's get a similar images, or it is trying to get different.
Can you try that text?
Yeah, same text. Let's give any one of the tests which we gave and see if it is giving similar stuff or it is improving or what is it like.
Okay, give the same text again.
Yeah.
Okay, I'm just for portrait for AI description and again trying to generate.
Yeah, let's see. Ideally, it should improve.
I don't think so. It will improve, but different images should get created.
Yeah, different images with better. Yeah. So yeah, it's fully different images, right? So, yeah. Yeah,
So it is probabilistic modeling. So it's
yeah.
from a Gaussian curve. So it will probably give different results each time.
But still, high probability should be always be same thing, right? The high probability should not change. That is what I'm trying to check out of this. Yeah. So there will be always some deficiencies with these models.
So can we create circuit diagrams with Dali? There's a question. I am doubtful of that. I don't think it has reached a level where you can create circuit diagram in VLSI design, let's say, or semiconductor design. So
it will look like that, but yeah, it's not able.
No, all the proprietary stuff, right? What companies have, that enterprise content and all the stuff, those are not kind of, I would say, indexed or kind of run. The model might have trained, but all the publicly available data only they could have done it.
Yes.
And like if you want to do this, they'll
text. Can you try when I pasted?
Sure.
So, to Suresh, on that point, this is based on CLIP. CLIP has been trained by scraping the entire internet or most of the internet. So they have used internet as sort of the comprehensive intelligence to train these kind of models.
Exactly. Yeah. So, a multi-ethnic group of blindfold co-workers touching an elephant. Oh, interesting.
Wow.
Looks interesting.
Yeah.
Hmm. Okay, so in interest of time, so any final questions or queries? So Gouthaman, are we kind of done?
Yeah. With this.
Okay, so any final questions, audience?
Gouthaman, can you just leave a
The algorithm we cannot
chat
think of doing
where
it,
to
right?
get this?
Ourselves.
Sorry, one by one.
Sorry, somebody's talking. I didn't hear.
So Gautam, I was saying that what is the mail ID where we have to kind of to send it to get that account here?
OpenAI, that is the thing. For Dali, there's a wait list. You can
Okay.
give your mail.
Okay. GPT-3 I did it, but never got it.
Dali, I think they're giving for many folks.
Is it? Okay. Okay.
How difficult it is to develop this algorithm by ourselves? It's very
Yeah, it's like we can try to create it, but
very expensive.
people have tried, like even the Dali, the open source thing. Only limitation would be like training the hardware and the amount of images. They'll be using like for the whole of the internet to train, right? So if we create with even with some thousands of images, it could, you would have little, the quality would not match up to this level.
Okay.
But I think for GPT, there was a lightweight GPT that came, right? I remember. Similarly, something might come with optimization. I don't know.
Probably.
So yeah, we'll be providing the recording on our CellStrat YouTube channel in, let's say, 2 weeks. So just subscribe to the CellStrat YouTube channel. And I think with that, we come to the end of this webinar. Any final comments, audience or Gouthaman?
Thank you very much, Gautam. Very interesting.
Yeah.
So there is
Especially
one question here. Do you have any algo on pattern recognition as well? So question is not clear to me at least. So Sunil, question is not clear to me at least. So this is not our algo. This is OpenAI algo what Gouthaman demonstrated. It's their latest, one of their latest algos. So by the way, OpenAI is a world-class AI lab, mostly owned by Microsoft now, and hence they have access to $1 billion in venture capital funding, and also they have access to massive Azure AI cluster on which they are able, and they have, I think, hundreds and hundreds of top-notch AI PhDs working in OpenAI. So replicating their work is not easy. We basically use most of their Hugging Face OpenAI algos as pre-trained models in our work, essentially. To replicate that, we probably need hundreds of millions of dollars of funding to be able to do that level of work. So, okay, with that, we come to an end of the session. Thanks a lot, Gouthaman. Excellent presentation, and look forward to more such sessions from you. And audience, thank you all for joining. If you have any questions about the work CellStrat does, as I said, we have courses, we have community and an AI platform, and we also have a job posting portal now. So reach out to us offline, and you can connect with CellStrat through LinkedIn. Many of us are on LinkedIn. Yeah. So with that, have a good day and stay safe.
Thanks for joining.
Thanks, Vivek, for conducting this.
Thank you.
Thanks, Gautam. Yeah.
Brilliant talk.